In this video, we're going to look at advanced linked lists. So this is a follow-on from the initial linked list video, which you should watch first to get an understanding of what a linked list is and how to create it. In this video, we're going to look at some of the different functions that you can perform on linked lists. But first, let's have a quick recap. So in the last video, we had some pseudocode for creating a linked list. So here it is, where we define a list node as our own sort of record data type, and it holds two items: the data item, which in this case is a character, but it could be anything, and a pointer to the next node in the linked list. And for the purposes of implementing this in a high-level language, we declare a list as an array, as a one-dimensional array of nodes. And this means that we can utilize the indexes of each of the elements in the array to identify each of our nodes. The initial or initializing procedure basically sets up the start pointer to be the null pointer. So in this case, because we have got a one-dimensional array starting at the 0 element, we can't use 0, so we use -1, something that will never occur as an index in our array. And then we set the free pointer to the first array index that is empty. So in this case it's 0, because the initial element in the one-dimensional array is currently empty. And then we link all the nodes together. So the fixed loop here loops for all the elements in the list, and then just adds these red numbers here. So the first array element links to the second links to the third, and so on until you get to the last array element. And because there's no more nodes in our linked list, because we have a fixed size one-dimensional array, we set its pointer to be the null pointer, which is -1 in this case. Before we describe the functions that you can now perform on your linked list, we have to introduce the idea of the linked list, but also the free nodes list. Because in fact, we've created two linked lists here. We've created the one which will hold the values and the one which holds no values, as in it's a list of nodes which are currently empty. And if you remember this from our sort of last lesson, we created some values in our linked list, but we left some empty. So in this example, we've got hello, one character for each node, and we just utilize the pointers which were set up in the initialize procedure. So that H links to E, E links to L links to the second L, and L links to O. Now, at this point, if we just wanted to display all the elements, all the linked elements in the list, it would automatically link 5 to 6, 6 to 7, and then 7 would signify the end of the list. So whoever wanted to display the contents of the linked list prior to this moment, it would display hello and then 3 spaces or 3 blank nodes. But we don't want to implement our linked list like that. We want to have a list which just contains the components H, E, L, and O, and then stops, whereas the free nodes are a separate entity. So we separate them out. And so our start pointer signifies the first node which contains a value, and our free pointer contains the pointer of the first node which does not contain a value. And this means that we can utilize these two lists. So for example, if we delete the H from the linked list, we can now utilize that node in the free nodes list. And so we could simply move it across to the free pointer, to the free nodes list, change the pointer of node that's identified as number 7, and have it pointing to node number 1 as shown. So as you can see here, we now have 4 nodes in the free nodes list and 4 nodes in the linked list. Other things to remember is that because we've removed the H, the start pointer has to change to 1 as shown. Other things to note is that we have changed the pointer of node that's in the location 7 of the array. It was previously the null pointer, but now we've changed it to point to the 0 element, which was previously h. And now that node in the free nodes list has the null pointer. And we'll just update this array at the top to show you what it looks like in real life. And there we go. So now we have the 7th element of the one-dimensional array has a pointer to position 0, and that is now the end of the free pointer list.